the James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. In this video, renowned physicist Michio Kaku unveils a monumental discovery made by the James Webb Space Telescope that could reshape our understanding of the cosmos. We expect the James Webb to make great discoveries. We expect it to challenge our assumptions about being the only place with intelligence in this galaxy. After years of anticipation, the JWST has finally captured groundbreaking images and data from the edge of the observable universe, revealing secrets that have eluded scientists for decades. Imagine a universe that is infinitely large. Put yourself in the middle, and you'll be watching that object being born. The James Webb Space Telescope has reportedly spotted galaxies dating even further back. What lies at the farthest reaches of space? How does this discovery impact our knowledge of the universe's origins, structure, and fate? Where are the aliens? That's one of the fundamental questions in cosmology, and the inquiry into the age of the universe stands as a cornerstone in this field. It is a profound quest to understand how long the universe has expanded since the monumental Big Bang. This explosive event gave rise to everything observable in the cosmos today. Throughout history, the universe's age has been a subject of intense debate, even within the scientific community. However, contemporary consensus among most cosmologists indicates that the universe is approximately 13.8 billion years old, with an uncertainty of less than 1% regarding the duration of its expansion since the Big Bang. Determining this timeframe commonly involves two primary methods. The first method assesses the universe's expansion rate using the Hubble constant, a metric derived from observing the velocity at which galaxies are receding from us. By estimating this movement, scientists can approximate the time that galaxies took to arrive at their present positions. The second method involves examining ancient stars in the universe, found in entities like globular clusters. Scientists can ascertain their ages with a high degree of certainty by analyzing factors such as brightness, color, and rotation rate in these ancient stars. By employing these methods, astronomers establish a minimum age for the universe, shedding light on its origins. Both methods provide compelling evidence that the universe is approximately 13.8 billion years old, with a margin of around 21 million years. Moreover, this age estimate aligns with numerous other observations and models regarding the universe's current state. Notably, it fits well with cosmic microwave background radiation data, representing the earliest light signatures we have captured from the universe post-Big Bang. However, despite the unity of results from these cosmological models, specific astronomical observations defy this estimated universe age. Some discoveries stand in contradiction, challenging our current understanding. A significant case in point is the star identified as Methuselah, in a study published in 2013. Scientists calculated Methuselah's age to be 14.5 billion years, exceeding the widely accepted age of the universe. Critics of the Big Bang theory frequently emphasize this anomaly as a possible imperfection in our comprehension of cosmic origins. Though Methuselah's existence might seem at odds with the Big Bang theory, critics often neglect a crucial factor: certainty. A more precise calculation places Methuselah's age at 14.45 billion years, with an uncertainty of 0.8 billion years. Over time, these measurements are becoming increasingly precise. However, the current estimate accounts for the moment, assuming the maximum uncertainty of 0.8 billion years. Methuselah fits within the acknowledged age range of the universe, approximately 13.65 billion years. But if the uncertainty is considered in the opposite direction, the star markedly exceeds our existing estimates, posing a significant challenge to current cosmological models. Another recent complication for astronomers is a discovery made by the James Webb Telescope. It stumbled upon a cluster of galaxies believed to have originated merely about 300 million years post-Big Bang. While this timeframe aligns with the current estimated age of the universe, the young age of these galaxies challenges our preconceptions about the formation of galaxies of this magnitude. Conventional wisdom regarding the formation of galaxies suggested their existence at this stage was implausible. They appeared more advanced in development than previously deemed possible within that era of the universe. Remarkably, they endured intense radiation and collisions with other celestial bodies. Consequently, these galaxies earned the moniker the impossible galaxies. The prevailing sentiment from these discoveries suggests a need for cosmologists to re-evaluate their models concerning early galaxy formation. Some question the accuracy of the JWST findings. However, what if our current assumptions are incorrect? What if these stars and galaxies are attempting to tell us that our understanding of the universe's age is fundamentally flawed, but we are hesitant to acknowledge it? Rendra Gupta's name was relatively unknown until recently. However, that has changed as Gupta, a professor of theoretical physics and cosmology at the University of Ottawa, is on the brink of making history. He is the only one offering two coherent explanations for the existence of dozens of galaxies deemed impossible at the outer limits of the known universe. Gupta's approach to resolution is straightforward, grounded in two theories that have been known for a century but were not taken seriously at the time. If Gupta's propositions prove accurate, we may need to adjust ourselves to an entirely new number for the age of the universe, 27 billion years, with an uncertainty of approximately 40 million years. Gupta substantiates his claims with compelling evidence. The implications of this discovery would be profound for the scientific community, particularly for those who have long adhered to the Big Bang theory and the prevailing estimate of the universe's age at 13.8 billion years. Should Gupta's study prove accurate and confirm a minimum age of 27 billion years for our universe, the implications would be monumental for our understanding of the cosmos. Numerous existing theories and models would need reassessment. Some would prove incorrect, while others might undergo revision and updating. This wouldn't merely translate to an increased workload for scientists. These advancements could also present an opportunity to address long-standing questions and mysteries about the universe's origin that have eluded us until now. For instance, an enduring enigma in cosmology revolves around what existed before the Big Bang. If the Big Bang marked the start of time and space, the question of what preceded it doesn't seem very smart. However, a deeper understanding becomes imperative if the Big Bang was not the absolute beginning but rather a transition between universes or the start of a multitude of universes. Perhaps there was a pre-existing universe before ours, or our universe originated within a much larger structure, something like an ancient multiverse-like entity with parallel universes and galaxies older than our universe. What if there are stars and galaxies scattered across the cosmos that predate the very existence of the universe? The concept might seem paradoxical, and indeed it is. However, these observations are not mere speculative musings, but founded in reality. As mentioned earlier, a solitary star Methuselah defied the expected age of 13.8 billion years. Researchers initially grappled with the possibility of a measurement error in an attempt to rationalize this anomaly. Then, in July 2023, the James Webb Space Telescope made startling observations. Dozens of galaxies seemingly older than expected emerged in its lens. These galaxies purportedly existed a mere 200 or 300 million years post the presumed Big Bang. Intriguingly, they exhibited extraordinary order and luminosity characteristics typically associated with galaxies evolving in the universe's early stages. Ordinarily, galaxies require billions of years to develop. When scientists traced back the developmental timeline of these seemingly advanced galaxies, they appeared to precede the universe's age. While some speculations entertained the notion of these galaxies as turbo-developers, such explanations lacked serious consideration. The revelations from the James Webb Telescope suggest a different narrative that challenges the established belief in the universe's age or even questions the very existence of the Big Bang. Presenting his solution, Rajendra Gupta has stirred enthusiasm among scientists since the summer of 2022. The prospect of a new worldview challenges rooted theories that many researchers have clung to, prompting a re-evaluation of established beliefs. As scientists grapple with the potential disruption of their current understanding, sleepless nights may become more common. Regrettably, not all astronomers and cosmologists are ready to embrace these discoveries as transformative. Some still cling to older explanations, resisting the call for innovation in the wake of James Webb's observations. Rajendra Gupta stood apart from those dismissing the possibilities as impossible. He swiftly offered a plausible explanation. Gupta drew inspiration from a theory formulated by Swiss scientist Fritz Zwicky in the 1920s. Zwicky's research on the redshift of galaxies led him to conclusions diverging from his contemporaries like Edwin Hubble and George Lemaitre. As light moves through space, its spectrum shifts from white to red over extended distances, causing the oldest galaxies to appear reddish in cosmic images. In contrast, the nearest stars emit a white or blue-white glow. Edwin Hubble discerned more than just the pure distance to us in the redshift, paving the way for new perspectives in astrophysics. Believing he had evidence that these ancient galaxies were not only present but also moving away from us, this observation led to the development of the Hubble constant, describing the rate at which the universe expands. However, despite being a cornerstone of the Big Bang theory, the expansion itself has yet to be conclusively proven, and skepticism persists. Nevertheless, the prevailing notion is that the universe has been continuously expanding since the Big Bang, an idea that Fritz Zwicky interpreted differently. Zwicky was convinced that light loses energy during its extensive journey through interactions with other particles, resulting in a redshift. Importantly, this mechanism doesn't follow an expansion of the universe and is seemingly incompatible with the standard model of cosmology. However, the innovative professor from Ottawa, Rajendra Gupta, offers a solution even in this context. According to Gupta's expertise, the tired light theory aligns seamlessly with existing standard models. To substantiate this, he employs another theory originating from 1937, the hypothesis of variable constants proposed by British physicist Paul Dirac. This hypothesis posits that certain constants employed to describe forces and particle masses are not eternally fixed, rather, they change gradually over time. Combining this notion with Dirac's hypothesis, Gupta introduces a novel model that addresses some of cosmology's most profound puzzles and mysteries. Gupta's model explains the existence of stars and galaxies that appear older than the universe by extending their formation and evolution time frame. Additionally, it explains why certain galaxies are smaller than anticipated, attributing their reduced mass to energy loss through light. Notably, Gupta's model challenges the cosmological constant, a parameter employed by scientists to calculate the age of the universe. This constant describes the universe's accelerated expansion, a phenomenon attributed to dark energy. Gupta substitutes the cosmological constant with a novel term contingent on variable constants, demonstrating a significant impact on our estimation of the universe's age. According to these computations, an age of 27 billion years appears most probable, with 40 billion years also within the realm of possibility. However, the apparent solution of variable constants introduces new challenges, and scientists aren't celebrating. The reason is straightforward: Dirac's theory of variable constants raises fresh issues. If particle behavior undergoes such dramatic changes over time that it results in computational errors, our ability to comprehend the early universe diminishes significantly. Zwicky's tired light hypothesis on its own falls short of explaining Webb's observations because it lacks the essential expansion component. Therefore, in pair with the tired light theory, Gupta introduces the covariant coupling constant, CCC, model. According to this model, fundamental constants such as the speed of light, Planck's constant, and the gravitational constant are not fixed over time. Instead, they undergo variations extending the timeline of the universe's evolution. By combining the CCC model with the tired light hypothesis, Gupta's work introduces a distinctive perspective on the challenges of early galaxy observations. This approach diverges from the CDM model, where a constant lambda explains the accelerating universe. Instead, the CCC model introduces another constant to account for the dynamic evolution of fundamental constants over cosmic time. Further scrutiny is needed to evaluate which model aligns best with the observations. Gupta explores various possibilities, including the tired light model in isolation, the combination of tired light with the CCC model, the combination of tired light with the CDM model by itself, and an alternative iteration of the tired light model. The combinations of CCC plus TL and CDM plus TL are particularly significant due to a compelling graph. The graph depicts the relationship between the redshift and angular size of galaxies. The blue marks denote galaxies observed at different redshifts before the James Webb Space Telescope, while the red marks represent galaxies observed by Webb. The curves illustrate how the angular size of galaxies varies according to different models. Notably, the currently accepted CDM model, depicted in green, exhibits a turnover at a redshift of approximately 1.5, diverging significantly from the observed galaxies beyond that point. In contrast, the CCC plus TL model, represented by the dark blue line, shows a gradual angular size reduction beyond Z greater than 10. This model aligns with observations made by telescopes preceding the James Webb and corresponds with the high redshift JWST galaxies. Aside from comparing theoretical models with observational data, the analysis also involved examining each model's predicted physical sizes of objects. Interestingly, the CCC plus TL model also exhibited an advantage in this regard. According to this model, the sizes of objects at higher redshifts were determined to be 15 to 20 times greater than what the CDM plus TL model predicted. This discrepancy in object size offers a plausible explanation for the observed substantial mass of high redshift galaxies, further reinforcing the credibility of the CCC plus TL model in addressing the challenges posed by early universe observations. According to the CCC plus TL model, the universe would be 5.8 billion years old at a redshift of 10 and 3.5 billion years old at a redshift of 20. This expanded time frame presents more opportunities for galaxies to form and evolve into substantial luminous structures, offering a more compelling rationale for the observed characteristics of high redshift galaxies. Among all the basic and hybrid models examined in the study, the CCC plus TL model possesses superior explanatory power. The amalgamation of the tired light hypothesis and the covariant coupling constant concept in this model has resulted in a more precise alignment with the observed data. If the universe adheres to the CCC plus TL model, its estimated age would be around 26.7 billion years. This challenges previous calculations and hints at the potential for a reassessment of our comprehension of the universe's timeline. However, further scrutiny and exploration are imperative to solidify these findings. Presently, scientists are already grappling with challenges in comprehending and describing the behavior of particles. Introducing the element of time-induced changes means that determining how old the universe is becomes nearly impossible or, in mathematical terms, highly elusive. Here we encounter a fascinating point invoking one of ancient time's most renowned scientists, Hermes Trismegistus. In the 2nd century BC, Hermes Trismegistus articulated the nature of the universe through a collection of verses known as the Hermetica. In this summary, the polymath explains the geometry and blueprint of the cosmos with formulas such as above, so below, and that which is within is like that which is without. What is in the large is also to be found in the small. Within the domain of quantum and particle physics research, there is a boundary that Hermes Trismegistus hinted at centuries ago. As researchers explore the infinitesimal realms, deconstructing atoms into progressively smaller constituents like electrons, neutrons, and protons, they come across particles like quarks. Although certain particles can be understood and measured, they eventually reach a critical point commonly termed fuzziness by German physicist Werner Heisenberg. Beyond this point, the behavior of particles becomes so unpredictable that precise measurement becomes elusive. The particles elude measurement at this level, and their description becomes challenging. Similarly, a transformation occurs above a particular threshold in large-scale phenomena along the temporal continuum. The behavior of particles undergoes a shift, rendering them challenging to detect or describe from our perspective. If this holds, we have now encountered cosmic fuzziness, aligning remarkably with Hermes Trismegistus' ancient prophecy. As in the small, so in the large, thousands of years later. This revelation prompts intriguing considerations about the future of astrophysics. Does this signify the conclusion of astrophysics? Certainly not. Human curiosity and technological advancements will likely propel us deeper into the cosmos of the smallest particles. It will foster the development of new methods to surmount the fuzziness threshold. Throughout history, scientists have consistently embraced new dimensions and ideas, refining their techniques to delve deeper into the intricacies of our world and the cosmos. The current challenges facing astronomy and cosmology are therefore not unprecedented. Despite our access to awe-inspiring images capturing more than 93 billion light-years of the universe and our ability to decipher numerous celestial phenomena, the cosmos remains a vast realm with material for millennia of research. Solving the enigmas surrounding the universe's origin has been a persistent human pursuit, and the quest to understand the universe's inception holds The promise of shedding light on the profound questions of our existence and its meaning should it be verified that our universe follows an unending cycle of birth, growth, and decay. These principles may transcend the boundaries of cosmology, influencing various aspects of our existence. Millennia in the past, ancient cultures such as the Vedas articulated the concept of a multiverse and the cyclic pattern of our being, that is, birth, life, death, and rebirth, portraying us as immortal entities. The certainty of Gupta's findings in his paper remains unknown at present. What we do understand, however, is that his work challenges many currently accepted models of the universe, necessitating a reconsideration of established frameworks. This presents a significant hurdle. The scientific process, adept at observation, testing, and verification, will now scrutinize Gupta's proposal. Determining the accuracy of his research is a task that lies ahead and may take some time. Do you believe these measurements of ancient stars and galaxies need to be revised or revisited, or does Gupta's work suggest a potential re-evaluation of our fundamental understanding of the universe's age? Is the universe genuinely 27 billion years old, or is this an instance of a physicist delving into the mysteries of the cosmos and getting too carried away? Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos like this. On December 26, 1994, some shocking images allegedly from NASA's Hubble Space Telescope began to circulate in the news. Upon closer investigation of the images, NASA's scientists in the United States were taken aback to see what appeared to be a massive white city floating in space. The NASA team was in disbelief and unsure how to respond when these Hubble images suddenly became publicly available on the Internet. Typically, such images are only accessible to experts in specialized space science facilities, but now they were rapidly spreading online. To manage the situation, the US government attempted to keep these images hidden from the public to prevent widespread panic or excitement. However, their efforts were too late. A photographer at Allington Airfield had already captured pictures of the images and was showing them to everyone who cared to see. These images showed an incredible space view with towers, pillars, caves, and other structures resembling human-made buildings. One of the images also contained a blurred section, which caught the attention of Ken Wilson, a professor at the University of Florida. Using a magnifying glass, Wilson closely examined the blurry area and noticed it had an unusual shape. This prompted the question of whether the pictures were real or merely a production of a transmission error from Hubble. However, after much analysis, it became evident that there was no error in the image transmission from Hubble to Earth. NASA experts further confirmed that the peculiar appearance was not due to any malfunction of the telescope's lenses. Following a quick meeting, NASA decided to retake the picture of the space region where the strange city-like structure was seen. They configured the Hubble telescope with optimal settings and focused it precisely on the area of interest. The telescope quickly captured new images, which were immediately displayed on a large screen in the lab. All the scientists present stopped what they were doing and turned their attention to the screen. The previously blurry and hard-to-see section was now clear. What they saw filled them with a mix of surprise and unease. The image depicted something self-illuminating resembling a city, but not like any city on Earth. Instead, it looked like a futuristic city from science fiction, with towering glowing buildings and an abundance of lights that simulated visions of another world. This immense city seemed to stretch endlessly into space, covering an area beyond human imagination. People began calling this place the City of God, with some speculating that it might be what heaven looks like. One NASA scientist even suggested it could be where spirits go after death, though such ideas sounded more like myths than real science. As the scientists continued to examine the Hubble images, they noticed more astonishing details. The city in space wasn't stationary, it was moving in a way that aligned with the movements of surrounding galaxies. This motion appeared to follow the same principles that underpin the Big Bang theory, which describes the origin and expansion of the universe. Despite its seemingly impossible nature, the city appeared to be part of the universe, obeying the same natural laws as everything else in the cosmos. The story became even more intriguing when scientists discovered something unique about the city's movement. Imagine watching a 3D map of the distant universe on a massive screen. It seemed as though it wasn't the universe moving away from us, but rather the Earth moving away from the city. This gave the impression that the city was at the center of everything. Scientists even created a computer model to demonstrate how other galaxies appeared to be moving away from the city. The deeper they looked, the more secrets and wonders the city revealed, like a giant cosmic puzzle. Each new piece they uncovered offered fresh insights into how the universe works. This prompted everyone to think bigger and wonder what else might be out there, far beyond what we can see from our small corner of the cosmos. But there's a twist in the story. Some people believe NASA tried to keep this astonishing image a secret. Why would they do that? This question has sparked much curiosity. Many speculate that NASA was concerned that revealing the picture might cause global fear. It seems hard to understand. It's as if there's something significant we're not being told. These incredible images, capable of altering our perception of everything, were hidden from almost everyone. Now, we delve deeper into this space mystery where things are not always as they seem, challenging our understanding of the stars and the celestial bodies beyond our sky. A careful look at the picture reveals numerous small detailed parts that make you question whether you're seeing just natural phenomena or something more. You can see shapes resembling tall buildings, large round structures, and even something similar to a castle tower. It almost seems like the photo is showing us a city in outer space arranged in a strange and unusual way. This raises the question of whether this place formed naturally or if something else is at play. Shockingly, in these structures, there were beings that looked just like angels. Yes, you read that right, angels. Initially, the scientists thought they had discovered a new group of stars because the colors in the image were so vivid and intense. But it soon became clear that what they were seeing resembled living beings. According to NASA, these angel-like figures were a striking shade of orange. Reports suggested that a group of these angels was seen flying together. They were captured on camera near the NGC 3532 star cluster, which has existed for 3 billion years. Initially, experts thought the unusual signals they were receiving were due to expected glitches with the $1.5 billion Hubble Space Telescope. However, upon closer examination, what they saw was astonishing. These angel-like creatures were each about 50 feet tall with enormous wings and surrounded by a sort of foggy halo. A person involved in space exploration mentioned that these beings had wings as wide as an airplane with calm round faces and expressions of pure joy. They seemed delighted to have their picture taken by the Hubble telescope, sharing smiles as if they were in on a cosmic joke. Interestingly, this isn't the first time someone has reported seeing angels in space. A Russian scientist who moved to the United States in 1985 shared stories of Soviet astronauts encountering a similar group of joyful, glowing angels during a Soyuz spacecraft mission. He believes there could be millions more angels out there in space. The team operating the Hubble telescope plans to continue their work. Now, it seems that the governments of both the United States and the former Soviet Union might be preparing to share groundbreaking news that could prove the existence of angels watching over us from above. Adding to the mystery, this fascinating image was shared with the public just one day after Christmas in 1994. The timing, for many, is intriguing because why release this image right after Christmas, a time of goodwill and reflection? Christmas is a season filled with warmth, caring, and deep contemplation. People celebrate joyfully, spend time with family and friends, and think about profound ideas like love, hope, and kindness. It's a time when people are more open to believing in miraculous things, things that transcend our everyday reality. Releasing the image right after Christmas seemed perfectly timed to capture the public's imagination during this period when people are still immersed in thoughts of wonder and mystery, making them more receptive to extraordinary stories from the stars. This perfect timing helped the story about this image spread rapidly, capturing everyone's attention. Whether the beings in this image are real or imagined remains uncertain. However, there's one thing we know: for years, there have been persistent rumors about NASA discovering something that could confirm long-held religious beliefs. Since scientists began exploring space, there have been tales of finding signs of something greater, something divine. Take, for example, a story from 2016 about a picture circulating on the internet that people claimed showed the gates of heaven in the middle of a star cloud. The accompanying story suggested that scientists were baffled by what they saw. However, this story was entirely false. The picture wasn't a real photo from space, it was artwork by Adam Ferris, an artist who uses a technique called pixel sorting to transform real space photos from the Hubble Space Telescope. For this piece, he started with an image of the Swan Nebula and rearranged the pixels, resulting in an image some people called the Gates of Heaven. Although it's good to know that Ferris never claimed his artwork was a real space photo, others later took his art and added the heaven story, making it seem like something it wasn't. In the quest for evidence of the divine in the cosmos, another rumor about a cosmic city awaiting humankind began to circulate. The story involved an image purportedly showing heaven, first shared by the publication Weekly World News under the headline Heaven Photographed by Hubble Telescope. This piece was originally published many years ago and resurfaced on the internet in 2009. You might recognize Weekly World News as the tabloid at the grocery store checkout famous for outlandish stories about bat-human hybrids or speculations that we all descended from space aliens. Despite its reputation for fantastical tales, this story about heaven caught many people's attention. The basis for this tale is shaky. It begins with real events, such as the Hubble Space Telescope being repaired, which was significant because it corrected an issue with the telescope's mirror, allowing it to take super clear pictures of space for the first time. The story then takes a giant leap, claiming that after the repair, astronomers used Hubble to look to the edge of space and supposedly saw a glowing city floating among the stars. The picture accompanying the story was equally dubious. Colored in black and white, it showed what appeared to be a distant city or perhaps a large house on a hill under a star-filled night sky. The image attempted to enhance its heavenly allure with rays of light shooting out in various directions from the city. However, many pointed out that these light rays actually undermined the image's credibility. Critics noted that the light beams were a clear sign that the image was not authentic, especially when compared to genuine photos from space telescopes like Hubble or the James Webb Space Telescope. In real space images, bright objects like stars often exhibit light lines known as diffraction spikes, a result of the telescope's construction. These spikes occur because of the interaction between the light and the telescope's mirror and structural supports. Each telescope's unique design results in different patterns of these spikes. For instance, diffraction spikes from Hubble might not look the same as those from the JWST due to their differing constructions and light-gathering methods. When experts investigated the supposed picture of heaven, they immediately noticed inconsistencies in the arrangement of these light spikes. In real telescope images, light hitting the large mirror can become slightly warped due to the mirror's shape and the metal supports holding it in place. While this warp doesn't significantly affect images of large diffuse objects, it becomes apparent when observing bright points like stars. These warps manifest as sharp lines extending from the star, known as diffraction spikes. These spikes are simply artifacts of the telescope's design and do not provide any information about the stars themselves. As such, the unlikeliness of the light spikes in the heaven image led knowledgeable observers to dismiss it as a fabrication. This further highlights the importance of understanding the nuances of astronomical photography when evaluating such extraordinary claims. However, there's an interesting twist. By examining the pattern of these lines, you can identify which telescope captured the picture? This bit of science raises doubts about the story claiming the picture shows heaven. The image in question features nearly a dozen of these spiky lines. The truth is, this doesn't completely disprove the story about NASA discovering heaven or that the picture is of something divine. However, it does cast doubt on whether the image is genuinely from NASA or if it's something else entirely. Imagine if the picture from the news story really did originate from space. If that were true, and we could prove it, almost all doubts about whether it depicts New Jerusalem or another heavenly city would vanish. Dr. Masson, who allegedly leaked the photo from NASA, claimed they captured the shot while aiming at a cluster of stars. It might take a photography expert to verify the photo's authenticity. However, a close inspection shows that the supposed city is surrounded by stars, suggesting it could be set in space. But here's where it gets tricky. The only ones who really know if this photo is from space are Dr. Masson, the folks at Weekly World News who reported it, and the NASA scientists allegedly involved. Since no one has managed to speak with any of these individuals, confirming if the photo is a genuine space shot is challenging. Regarding the timing, the Hubble Space Telescope indeed underwent repairs in 1993. Weekly World News reported that the fixes were completed by mid-year and the first pictures after the repair were sent back to Earth on December 26, 1993. This timeline fits with information from other sources, which state that the repairs wrapped up on December 9, 1993, and the official Hubble site indicates that NASA published these new pictures on January 13, 1994. Therefore, the pictures must have been sent to Earth sometime between December 9, 1993, when the repairs were finished, and January 13, 1994, when they were publicly displayed. The December 26 date mentioned by Weekly World News falls within this window, making it plausible. Weekly World News first discussed these so-called heavenly images on February 8, 1994, and revisited the story on September 10, 2009. There's nothing in these dates that directly conflicts with what we know from other sources. Thus, while the timing supports the possibility of the image being genuine, the presence of the diffraction spikes and the lack of verification from credible sources continue to cast doubt on the story's authenticity. While their story may seem far-fetched, the timeline they provide aligns reasonably well with the real-world sequence of events surrounding Hubble's repairs and the release of its photos. Now let's connect past space missions to today's space mysteries, illustrating how discoveries in space reshape our understanding here on Earth. On December 2, 1993, the Space Shuttle Endeavour embarked on a significant mission with 7 astronauts. Their objective was to repair the Hubble Space Telescope. Over 5 days of space walks, akin to strolling outside but in space, they executed various tasks. They replaced a component called the high-speed photometer with something called CoStar, upgraded the telescope's camera to the WFPC-2, swapped out solar panels, fixed fuse plugs, and replaced other components. By December 9, their extensive repair work was complete. Then, on January 13, 1994, NASA unveiled the first batch of photos captured by the newly refurbished Hubble. And they were breathtaking. The images were remarkably clear and detailed, as if Hubble had been equipped with a new pair of glasses, enabling it to observe the universe with unprecedented clarity. This marked the moment when Hubble truly began to fulfill the lofty expectations people had for it. Now, let's shift our focus to something equally fascinating that Hubble observed. Imagine gazing into the vast depths of space and encountering not just ordinary stars but peculiar ladder-like patterns swirling around a dimming star. This phenomenon, discovered by Hubble, evokes thoughts of the legendary city of God in space. Even though we haven't uncovered the mythical stairway to heaven, the sight of these ladder shapes around the star raises numerous questions and feels like unraveling a cosmic enigma. In addition to this, there's the Red Rectangle Nebula, also known as HD 4179. This nebula earned its moniker because, when observed with conventional telescopes from Earth, it appears as a distinctive red rectangular shape. However, Hubble, with its unparalleled vision, has unveiled a wealth of previously unseen details about this nebula. Thanks to its advantageous position above Earth's distorting atmosphere, the red rectangle has emerged as a genuine puzzle, reminiscent of the intricate and mysterious descriptions we've heard about the so-called City of God. This nebula is filled with remarkable features, including patterns resembling steps or perhaps a spider's web. These patterns are not mere decoration, they consist of gas streaming out from the star in an organized manner, similar to overflowing wine glasses stacked within each other. Hubble's exploration of this nebula has presented us with surprises about the workings of the universe. Much like the complex structures of the supposed celestial city, originally dubbed the Red Rectangle Nebula due to its appearance resembling a red box from Earth, it has upended expectations by revealing itself to be more of an X-shape than a rectangle. This revelation challenges some of our preconceived notions about celestial phenomena, echoing the unexpected shapes and patterns associated with the City of God. Both entities defy conventional understanding, prompting scientists and enthusiasts alike to re-evaluate their understanding of space and its mysteries. At the heart of the Red Rectangle Nebula lies a dying star shedding its outer layers and forming a distinctive shape resembling two cones touching at their tips. Periodically, the star ejects rings of gas and dust, akin to the unusual occurrences described in the City of God. It's as if both the star and the city are sending secret messages, suggesting a potential connection between these cosmic phenomena. This underscores the notion that space is brimming with wonders yet to be fully understood. From the intriguing ladder-like patterns around star HD 4179 to the legends of a heavenly city, these remarkable discoveries underscore the wild and unexpected nature of the universe. The detailed images obtained from super-advanced telescopes serve as an invitation to delve deeper into space, urging us to challenge our preconceptions and unravel the secrets scattered across the boundless cosmic landscape. The true magic of this narrative, whether it relates to myths of heaven or not, lies in our continuous fascination with the mysteries of the universe far beyond our own galaxy. This curiosity is ignited and nourished by the extraordinary images provided by the Hubble Space Telescope. Now, you might wonder how this remarkable instrument carries out its mission. Floating high above Earth's atmosphere, Hubble occupies a strategic position where it can capture images without distortion caused by atmospheric interference. It swiftly orbits the Earth, completing a full circuit roughly every 97 minutes. Hubble's primary task is to gather light from stars and other celestial objects, producing incredibly sharp images and collecting detailed data. Its vantage point above the atmosphere eliminates the twinkling effect observed when viewing stars from the ground, yielding clearer insights into the cosmos. Although Hubble isn't the largest telescope, its 7.8-foot mirror is relatively small compared to some ground-based telescopes. It excels in its mission. This is possible all thanks to its ingenious design and cutting-edge technology. The demand for Hubble's observation time is immense, prompting careful scheduling to maximize its scientific output. At the core of Hubble's excellence lie its scientific instruments, which serve two primary functions: capturing stunning images. Analyzing the light from stars and galaxies to understand their compositions is similar to dissecting the colors of a rainbow. Positioned high above the atmosphere, Hubble detects various types of light, including infrared and ultraviolet, which are inaccessible from Earth's surface due to atmospheric absorption. Positioned in space, Hubble provides us with a perspective inaccessible to ground-based telescopes, unveiling new perspectives into the mysterious depths of the universe. Now, let's delve into the remarkable tools and collaborative efforts that enable us to unravel the mysteries of space. Each new set of space images beamed from distant galaxies by the Hubble Space Telescope resembles the work of a sophisticated space detective equipped with an array of specialized gadgets. Among these tools are the Advanced Camera for Surveys, ACS, and the Near-Infrared Camera and Multi-Object Spectrograph, NICMOS, each with its specific function. This includes capturing visible light and detecting invisible infrared radiation. However, Hubble doesn't operate in isolation. It functions as an integral component of a vast, intricate mechanism. Using solar panels to convert sunlight into power and relying on gyroscopes, star trackers, and reaction wheels to maintain precise orientation, Hubble remains steadfastly focused on its celestial targets. This stability enables Hubble to capture incredibly sharp and detailed images, sometimes fixating on a single point for hours or even days without deviation. However, the journey of data from Hubble to Earth is an adventure in itself. After transmitting its discoveries to a dedicated satellite orbiting high above Earth, the data is relayed to White Sands, New Mexico, USA. From there, it travels great distances, crossing oceans until it reaches its final destination. The data is collected in a sprawling archive in Munich, Germany, storing it for scientists worldwide to explore. What truly sets Hubble apart isn't merely its scientific achievements, but also the collaborative spirit that brings it to fruition. It signifies a harmonious partnership between NASA and the European Space Agency, ESA, in Europe. This collaboration extends beyond the sharing of tools and data. It embodies the synergy of individuals from diverse backgrounds working together, exchanging ideas, and contributing to our collective understanding of the cosmos. European scientists, in particular, leverage Hubble for their own research endeavors, enriching the vast understanding of space knowledge with their discoveries. The Hubble Space Telescope is more than just an object floating in space. It embodies the spirit of mankind's inquiry and cooperation. Thanks to its remarkable technology and the work done for it, our understanding of the universe has changed, and many observations once unobtainable have become possible. With Hubble as our cosmic guiding light, we unravel the mysteries of the universe a fragment at a time as we perpetually push our boundaries and expand into the cosmos. Since its launch in 1990, the Hubble Space Telescope has served as a door opening to the wonders of the cosmos. However, its importance is not limited to obtaining visually appealing images of celestial bodies. In addition to being one of the largest and most powerful telescopes in the world, Hubble boasts a collection of instruments that enable it to observe a wide range of light from the visible to the non-visible spectrum. This makes it invaluable to astronomers, as it can provide glimpses into the most distant corners of the universe. Thanks to Hubble, we have learned a lot about the formation and growth of galaxies, stars, and planets, which has helped expand our horizons with knowledge regarding the history of cosmic events. Despite being in space for over 20 years now, the Hubble Space Telescope's mission is very much alive. Hubble has imaged more than 1 million objects in space and has contributed over 21,000 papers to the body of astronomical knowledge, extending the story of human understanding of the universe. Nevertheless, the journey of the Hubble Space Telescope is far from over. With each observation, it provides another piece to the cosmic jigsaw, giving answers to some questions while posing new questions for the continuing search for the meaning of the universe.